Hold on, I gotta make sure it's okay. Okay, I just had to make sure that the microphone was on. Okay, so what were the points of discontinuity for A?
Wait, what?
-3 and so that was the whole -1. So those were your discontinuities. Correct? Which one removed? Which one were we able to remove? -3. So this was removable. So it created a hole, right? What was the coordinate of that hole? Yep.
-3 and -1/2. Wait, what?
Oh, guys, you're right. It's 1 over -2. Okay, so when you reduce this, this equals 1 over x plus 1. Sorry, for those of you that I said it was right, it was because I was missing that 1. This is 1 over this. So this would be 1 over -3 plus 1, which equals 1 over -2. Okay, we good on that?
So it's
-1/2. -3 comma -1/2 is my whole. -1, what kind of discontinuity was that? Non-removable. Which means it was a vertical asymptote at x equals -1. Good?
Can you find the x-intercepts?
The x-intercepts, you take the numerator and set it equal to 0. X plus 3 equals 0. Which means
You go -3, so x equals to -3.
okay, here's my question.
What do you do from there? Because that's not the coordinate point. Is it just 0?
What's the coordinate point of an x-intercept?
Oh, it's 0. So you just go -3, 0.
However,
There should be 2.
no,
No?
there doesn't have to be 2. If there's 2, if it's a quadratic on top, it'd be 2. Okay, can someone tell me what's wrong with this for x-intercept?
It's the excluded value.
It's the excluded value. So what happens at that x-intercept? There's a hole. So does it actually cross the line?
No.
No. That means if your x-intercept is your excluded value or your hole, there's none.
How is that?
So there are no x-intercepts on this equation. The graph looks like it, but it actually jumps over the line rather than going through the line. Okay, we good?
What?
You guys are doing great. So how do we find x-intercepts of a rational function?
See something.
I don't know how to do the other.
Set the numerator equal to 0. When will we not have any x-intercepts on a rational function then?
No x.
There are no x's in the numerator. So for example, 1 over x plus 2 has no x-intercepts because 0 equals 1 is not true. Okay, when will we have a hole in a graph?
You 6 are screwed. It is freezing right here. I can feel the breeze. These poor 6 chairs.
Dang.
I'm standing here like, no joke. Go check for frostbite.
Sad.
Jeez, sorry, I didn't. I'm just
No, it's fine.
surprised, though. It really is cold, right?
When do we have a
The desk, right?
when do we have a hole in our graph? Yes. Sorry, I didn't hear. It's an excluded value that is
just that one spot where they move the desk. Just go stand over there.
So it's the removable
It's terrible.
that reduces to 1. Okay, removable discontinuity.
Maybe it's the giant coat you're wearing.
The vertical asymptote is the excluded value that doesn't reduce. Non-removable. Blah, 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 blah.
You can put non-removable.
D. Okay. Horizontal asymptotes are found by, I'll give you that word, because this was like last class. How do you find the horizontal asymptotes? We did that last time. Degrees, compare the degrees. Okay, good. You guys did awesome.
If it were me, I would take this page we gave you last time, which is like a how-to for everything, and maybe just add the word holes right here, and then put like how-to holes. Then you have all of the things on one page. That's what I would do if it were me.
Completely agree.